This video is brought to you by the Environmental Protection Agency. The use of any trade names or commercial products does not constitute an endorsement on the part of the Environmental Protection Agency. For the arsenic rule, EPA evaluated several technologies as candidates for best available technology for arsenic removal, including modified coagulation filtration. Typically, coagulation filtration treatment uses the process of particle destabilization to remove colloidal and suspended matter from the water supply. This process results in the formation of flock particles that are removed by clarification and/or filtration. The coagulants that are commonly used are aluminum or iron salts that form particulates that attach to the suspended or colloidal matter. Increasingly, polymer aluminum-based blended chemicals are being used for the removal process. The installation of these conventional gravity coagulation filtration systems solely for arsenic treatment is generally uneconomical. However, the process of coagulation filtration can be modified to remove dissolved inorganic matter, including arsenic. Typically, if a source has arsenic-3, oxidation, usually chlorine, is used to convert arsenic-3 to arsenic-5. A coagulant, in this case, ferric chloride, is added to be oxidized, producing iron hydroxide particles. The hydroxides in arsenic-laden water are held in a retention tank to allow the co-precipitation and adsorption process to occur. The arsenic and iron precipitates are filtered from the water, in this example by a pressure filter vessel. The filters are allowed to load with the precipitates until the filter is partially loaded, and then the filter is backwashed. The backwash waste is directed to either a sanitary sewer or dedicated waste system. Not many surface waters have elevated arsenic concentrations that are of a concern to public water supplies. However, the Yellowstone River, which originates in the volcanically active area of Yellowstone Park, is an exception. There are numerous public water systems that rely on the Yellowstone River as their source water and use coagulation filtration as their water treatment process. Two such systems are the city of Billings, Montana, and the Lockwood Water District. With the revised arsenic MCL looming in the future, the city of Billings began experimenting with coagulants other than alum to increase arsenic removal. Billings converted to ferric chloride as a coagulant.
Arsenic in the Yellowstone River, because it's a surface water source, is arsenic-5. Arsenic-5 is relatively easy to remove. Our treatment system here is a full conventional plant. We coagulate, flocculate, sedimentation, and then through filtration. We use a polyaluminum hydroxychloride, PACL, which is an alum blend, a proprietary alum blend. Prior to that, we used ferric chloride. Prior to that, we used alum. We went to ferric chloride because of our arsenic problems and when arsenic became an issue in the early 90s.
The Lockwood Water District continued to use alum as a coagulant. This provided an excellent full-scale comparison between aluminum and ferric-based coagulants.
We have treated with aluminum sulfate in the past and polymers that we use for that. Usually we got roughly 50% removal of the arsenic.
As seen on the graph, the Billings finished water arsenic concentration was consistently below the detection level, less than 2 micrograms per liter. In the Lockwood plant, alum removes significantly less of the arsenic. The city of Billings has since converted from ferric chloride to an aluminum polymer blend to reduce some corrosion problems attributed to ferric chloride. As long as the arsenic concentration in the Yellowstone River is less than 15 micrograms per liter, the polymer blended coagulant works for arsenic removal. If necessary, the city adds a small amount of ferric chloride to aid in removal of arsenic.
Our approach here is to also use ferric chloride. When we get above 8 micrograms per liter in our finished water, we start adding ferric chloride.
This is also being considered for Lockwood.
Right now, like I say, we are testing a polyaluminum hydroxide. We're not sure if that's the polymer, of choice or the coagulant of choice. Right now, we want to be able to feed a little bit of ferric to get rid of the arsenic, but we want to get that into some level that's more controllable for pH. But I would imagine that that's probably where we'll be 6 months from now.
Both the City of Billings and Lockwood Water District have tested the sludge. Neither demonstrated hazardous waste characteristics.
We've tested for the arsenic levels. The sludge processes that we use, sending out to a sludge drying pond, have that tested for metals content, and it's showing that we can land apply that. So to this point, we haven't had a problem with land application instead of having to take it to a landfill.
We have T-clipped that sludge. The TCLP test to date has been non-detect on arsenic.
Climax, Minnesota is also using coagulation filtration to remove arsenic. This system is participating in the United States Environmental Protection Agency Arsenic Demonstration Project, Round 1. Climax has two 140-foot deep wells. The wells have a flow capacity of 140 gallons per minute and 160 gallons per minute. However, only one well is operated at any one time, with the two wells alternating on a monthly basis. The wells have about 35 micrograms per liter of arsenic, primarily arsenic 3, and 0.5 milligrams per liter iron. This represents an iron to arsenic ratio of less than 20 to 1, the ratio needed for efficient arsenic removal. The demonstration project added a skid-mounted system of 2 coagulation contact tanks and 2 pressure filtration tanks. The major components in the treatment process are pre-chlorination. The original gas chlorination system was replaced with a liquid chlorine feed system to improve the reliability and safety of the chlorination system.